Welcome to Understand the Math. In this video, I'm going to show you two important tools for working with polynomials, the Remainder Theorem and the Factor Theorem. They provide shortcuts for evaluating polynomials and finding their factors or zeros. Let's start with the Remainder Theorem and look at some examples. The Remainder Theorem tells us that if a polynomial, f of x, is divided by x minus c, then the remainder is just f of c. I'll show you where this comes from. Here's our polynomial f of x, and we're dividing it by x minus c. It's going to equal our quotient, q of x, plus our remainder divided by x minus c. If we multiply both sides of the equation by x minus c, we just get f of x. And then if we plug in that x is equal to c, we get that f of c is our remainder. Let's see how this is used and go over two examples. In our first example, we are going to use the remainder theorem to find the remainder when we're given that f of x is divided by x minus 1. This just means that x minus 1 is equal to x minus c, which means that c is equal to 1. We can use the remainder theorem to find the remainder. The theorem tells us that our remainder r is equal to f at 1, because c is 1. And if we plug in 1 into x in our function, we're going to get 2 minus 4 plus 6 minus 1. If we add the first two numbers, we get minus 2. And then if we add the last two numbers, we get 5. And this gives us a value of 3. So the remainder theorem tells us that the remainder is equal to 3 when we divide f of x by x minus 1. Let's now look at another example. This is a pretty typical example. And in this example, we're asked to use synthetic division and the remainder theorem to find f of 3 when we're given a function f of x. Our remainder theorem tells us that f of 3 is going to be our remainder when our f of x that we're given is divided by x minus 3. So what we're going to have to do is use synthetic division to divide f of x by x minus 3, and then the remainder that we get is going to be f of 3. I have a video on synthetic division if you need to review that. When we do synthetic division, we start by drawing a corner. And in that corner, we're going to put the value where x minus 3 is equal to 0, and that's x is equal to 3. So in other words, we're just plugging in 3. Let's put that down. That goes in our corner. And then we're going to go back up to our function, and we're just going to look at the constants multiplying x. And then our last number multiplies x to the 0. Let's go ahead and let's put these down. We have 2 minus 5, 3 minus 7, and 1. We're going to draw a line, and we're going to begin by pulling down our first constant, and that's a 2. Now we're going to multiply, and we're going to multiply 3 times 2, and we get 6, and we put it right there. Then we're going to add, and we have minus 5 plus 6 is 1. Now we're going to multiply again. We're going to multiply 3 times 1, and we're going to get 3. We're going to add 3 plus 3, and we get 6. Now we'll multiply 3 times 6. We get 18. And then we'll add 18 and minus 7 and get 11. And then we'll do one last multiplication. 3 times 11 is 33. And we'll add 1 and 33, and we get 34. I'm going to highlight 34 because that is our remainder. So this tells us that f of 3 is equal to 34. I know we could have found f of 3 by just plugging 3 into our function, but when you have lots of terms in your function and lots of coefficients, this method is almost quicker than just directly plugging in that x is equal to 3. Let's now go over the factor theorem and look at some examples. The factor theorem tells us that x minus c is a factor of f of x, and c is a 0 of f of x if and only if f of c is equal to 0. This is a really great theorem because if we're looking to see if a constant c is a 0 of f of x, or x minus c is a factor of f of x, then all we have to do is evaluate our function at the point c and see if it's equal to 0. Let's look at some examples. In this first example, we're asked, is x minus 1 a factor of f of x? From the factor theorem, we know that x minus 1 is going to be a factor of f of x if f of 1 is equal to 0. So that's what we're going to check. We're going to let x be equal to 1 and see what we get. Let's go up here to our function, and we're going to let every x be equal to 1. This gives us 1 minus 4 minus 7 plus 10. If we add 1 and minus 4, we get minus 3. And then if we add minus 7 and 10, we get 3. And we add those up, and we get 0. Since f of 1 is equal to 0, we can conclude that x minus 1 is a factor of f of x. We can also say that 1 is a 0 of f of x. So the factor theorem is just really nice. Just by plugging in a number, we can tell if that number is a 0 of our function. Let's look at another example. In this example, we're going to be asked to determine if 2 is a 0 of f of x. It's very similar to the first question, it's just worded differently, and I wanted to do both of these so that you can see the different wordings that you might encounter. To answer this question, what we're going to do is just like we did in our first example, we're going to take our function and we're going to plug in that number. So this number is 2, so we need to evaluate f at 2. We're going to go back up to our function, and wherever we have an x, we're going to plug in 2. So this is 2 times 2 cubed plus 2 squared minus 5 times 2 plus 4. 2 cubed is 8, and then 8 times 2 is 16. So this is 16. 2 squared is 4, and then we have minus 10 plus 4. If we add the first two numbers, we get 20, and then minus 10 plus 4 is minus 6, and this gives us a value of 14. Let's highlight that. And now let's think about our answer. We ended up finding that f of 2 was equal to 14, and this was not equal to 0. And because it's not equal to 0, we can conclude that 2 is not a 0 of f of x. And that's it. Thanks for watching. If you found this helpful, be sure to check out the next video in this series where we go deeper into factoring and find all the zeros of a polynomial.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.